Good evening, Mr. Chang here. Nighttime, dark, weird lighting, cutting some videos. Want you guys to have everything you need to be successful. We're going to be talking about lines and how to write the equation of a line by looking at a graph. Okay, when you see the graph of a line, can you look at that line, that graph, and create an equation from it? You're going to learn that skill today in this video. So let's start with a little bit of conceptually, what are we doing here and why? So I'm going to take you guys back to our lecture we've really been doing this for like maybe 3 lectures, and I'm going to try and compress everything down together quickly. You may recognize this, but what you're looking at right here is just a blank graph. But I want to point your eyes to this equation, y equals mx plus b, y equals mx plus b. This is the generic equation of a line, generic, okay? Y equals mx plus b. It's all letters. There's no numbers in there. Crazy. There are 4 variables in here. What does that mean? Well, this is the generic equation of the line. And this basically, the word generic means it could apply to any line. Apply to any line. Generic means it is not specific, and it relates to a whole category of things. So in this case, y equals mx plus b could be any line that you see on a coordinate plane. It could be this line, it could be the second line I drew, it could be a line that looks like this, it could be a line that looks like this. Any line can be defined by the generic equation y equals mx plus b. So y equals mx plus b, y refers to the y coordinates going up and down, right? So that red y means your y values going up and down. The x, you see in green, refers to the x values going left and right, horizontal and vertical. The letter m is the slope of the line. That's its steepness. And the letter b refers to the y-intercept, which is where a line will cross the y-axis. So now that you see the generic form, the generic equation of a line, y equals mx plus b, what you need to know is that if you have a number for the slope, if you know what the slope is, and you know where a line crosses the y-intercept, if you know the slope of a line and where it crosses the y-axis, you know where its y-intercept is, then you go from generic to specific. So for instance, the equation y equals 2x plus 1 is a very specific equation because it's got a y-intercept, right? The number 1 is the y-intercept, and that replaces this b, okay? And it's got a slope. It's got a slope of 2 right here. The slope is 2, and that replaces the m. So y equals mx plus b. I replace the m with a slope of 2. I replace the b with a y-intercept of 1. And now if I put numbers in for the m and the b, I have an actual specific equation of one line and one line only. That is a line that crosses the x-axis at 0, 1. That's the y-intercept right there. And it has a slope of 2, which we know means that it has a vertical for every 1, 2, 2 squares in height. It goes 2 squares over. In horizontal distance. So that here is a line. This red line, that is what is represented by y equals 2x plus 1. So you go from something that is generic, that could be any line in the world, in the universe. And if you tell me what the slope is of this line and you tell me where it crosses the y-axis, if you tell me the y-intercept, then I go from generic to specific. And I have y equals 2x plus 1, and that is the equation of one line and one line only. So that is what we're going to be doing right now. You are going to be taking the generic form of a line, y equals mx plus b. You're going to find the slope of a line. You're going to find the y-intercept of a line. And you're going to substitute the m, the letter m, and the letter b with slope and y-intercept, actual slopes and actual y-intercepts of an actual line, and you are going to go from generic to specific. That is what we're doing here. All right, so now that you've got conceptually what we're doing, going from a generic line, y equals mx plus b, to a specific line where you're using actual numbers for the slope and the y-intercept, let's actually go over to our favorite thing in the world, iXL, and practice this on a few problems. So I'm going to share a new screen. I'm going to iXL. Here we go. Switching, actually, I'm going to do it like this. New share. We're going to go to share desktop 1. Boom. All right, now you're staring at desktop 1, and now we're also going to look for this. Voila. All right, here we go. Here's a 4-step process for taking the generic equation of a line, y equals mx plus b, and getting to a very specific equation of a line. So here we are. We are at WHM. This is a graded iXL skill for you. WHM. And our goal is to take this generic equation, y equals mx plus b, and turn it into a specific equation for this line. We got to figure out how to take y equals mx plus b. We got to figure out the slope, and then we got to figure out the y-intercept and go from generic to right there, specific, this line. We are going to come up with an equation that represents this line. Okay? So I think there's really 4 steps to do this efficiently. There's a lot of different ways to do this. I'm going to show you what I think is the most efficient way. And here are the 4 steps. And everything is color coordinated, and I'm going to try and color coordinate everything I do as well. So the first thing we want to do is actually, we're going to try and find the y-intercept. We're going to try and find b. So remember, the letter b is the variable we use to represent the y-intercept. Okay, so that's step 1, find the y-intercept. I'm going to write down the coordinates, 0, comma, whatever the y-intercept is. So that's step 1, and I'm going to do that in purple. Step 2 is we're going to find a second point on this graph where the black line intersects the 2 gray grid lines behind it. And we're going to find a second point. That's step 2. Then step 3, we're going to do in blue, which is we're going to use the slope formula, and we're going to use the y-intercept, and we're going to use the second point that we find in step 2, and we're going to calculate the slope of the line. And the slope of the line is represented by this variable m. Okay, so we're going to find b, the y-intercept, little b, in step 1, And then we're going to find the slope, little m, in step 3. And once you have the slope and the y-intercept of a line, then you can create an equation for that specific line. And the way you're going to do that is you're going to substitute the slope and y-intercept, the actual numbers that you calculate for slope and y-intercept. You're going to substitute the slope and the y-intercept for the letters m and b in the equation, and you will have a specific equation that's in the same form, y equals mx plus b, but you're going to have real numbers. Instead of the m, you're going to have, and the b, you're going to have real numbers, so that you have a specific equation that can only be matched to one line. All right, I've talked a lot. Let's make this happen. Let's make this happen. So I'm just going to follow the steps. First things first, I got to find my y-intercept, and I'm going to write it down as a set of coordinates. And the y-intercept is where your line crosses the y-axis. And right here, it crosses at the origin, right? You see this black line? It's coming straight down. It's going to cross at the origin. So my y-intercept, step 1, my y-intercept, which is going to be the little, which is also the b, right? The little b stands for your y-intercept, where your line crosses the y-axis. That is the point 0, 0. Step 2, I'm going to do that in green. I'm going to find a second point where the gray grid lines intersect the black line. So I'm going to follow this black line all the way up right there. That's my second point. And my second point is going to have the coordinates, it looks like 10, 60. So that's step 2. Now I'm going to do step 3 in blue, which is to calculate the slope, right? I'm going to use my formula y2 minus y1, x2 minus x1. I'm going to make my y-intercept 0.1. I'm going to make my second point 0.2. That makes this 60, y of 2. Let me use red. I always use red. Y of 2, that makes 0, y 1, y of 0.1. That makes my 10, x of 0.2. And that makes my 0, x, my 0 and my y-intercept, x of 0.1. Now, let's do the formula. I'll do my x's first. So that's 10 minus 0. And I'll do my y's second, just because of my pen color. That's 60 minus 0. This is really easy. My slope is 60 over 10. Remember, I have to simplify my slope. And the common factor here, 6 and 10, 60 and 10 is 10. So I'm going to divide out 10 from both sides. I'm going to be left with 6 over 1. I'm going to simplify that even further. And I know my slope is 6. And I'm going to write this in blue, because slope, little m, equals 6. Okay? So I've got my slope. So I've got my slope, little m, is 6, and I've got my y-intercept, little b, all the way in step 1. Y-intercept is 0, 0. Now I'm going to move on to step 4, and I guess for step 4, I will use just good old black for step 4. I'm going to take this equation, y equals mx plus b. And let me just erase the m and the b and use my actual colors. So b is always purple. Slope is always blue. And I'm going to take and replace the m, the letter m and the letter b with the actual numbers that I calculated. So the actual slope I calculated is the number 6. So I'm going to substitute the m with the 6. And my actual y-intercept is the y coordinate right there. from step 1, and I'm going to substitute that for b. And the reason why I asked you to write this as a coordinate form is so that you could use the y-intercept in your calculation of slope. So now what do I have? I've got my final equation is y equals 6x plus 0. There you have it, 6xy equals 6x plus 0. That is your final equation, and that is what represents this black line all the way over here. This is represented by the equation y equals 6x. And because you plus 0, you don't need to put plus 0. You don't need to attach that to your equation anymore because 0 is nothing. So we can just get rid of that. Because it has a y-intercept at the origin, your equation is just y equals 6x. There you go. We've gone 4 steps right there. Hopefully you're rewinding this and watching me do this over. I'm going to do a couple more examples. But let's see if we get a little love from our friends at iXL. So remember this thing, they're asking, what is the equation of the line in y slope intercept form? That is the question. We are giving it to them, y equals 6x. This is in slope intercept form. Remember, we have the y-intercept is 0. So because it's 0, we don't have to put it in. So y equals 6x is totally fine. How are we doing? Yes, we did it. We got it. Hooray. Let's do another one. Look at this tiny little line here. My goodness. That doesn't bother us. We can deal with tiny lines. There are our 4 steps. One more time. We're going to take the generic equation of a line. This could be any line in the world, y equals mx plus b, and we're going to turn it into a specific equation just to represent this tiny little line that you see on the left. So what is the equation of a line in slope-intercept form? Here we go, step 1 in purple. We're going to find the y-intercept, and right there, that is our y-intercept. Where that line touches or crosses the y-axis, that is our y-intercept. So step 1, our y-intercept, little b, and I'm just going to try and make this really clear. Your y-intercept, or little b, is 8. Specifically, it is at the coordinates 0, 8. Wherever your x coordinate is 0, that on a line, that is where your y-intercept is. So this point right there is 0, 8. And the reason why your y-intercept is actually the number 8, so that is b. But the reason why I'm writing this full coordinate out is because I want to use it in step 3, which is where we calculate the slope. So step 2, using green, I got to find another point where this black line crosses the gray grid lines behind it. And I've got a lot of points I can use. This looks like a good one right there. This at the top also would work. So I'll use this point, which looks like 1, 9. So that is my second point where my black line intersects the gray grid lines behind it. So I've got 1, 9. Step 3. This has to be something that you guys are really excited about, which is to find the slope. So let's say that we've got 1, 9. That will be my point 2. And 0, 8. That will be my point 1. And y coordinate of point 2 is 9, and the y coordinate of point 1 is 8. So I'm going to mark those as y1 and x2, y2 and y1. And then the number 1 is my x coordinate 4.2, and the number 0 is the x coordinate of 0.1. So that's x2 and x1. Now I use my formula. Let's go. First, let's find the vertical change. That's y2 minus y1, which is 9 minus 8, divided by x2 minus x1, which is 1 minus 0. So lo and behold, look at this. We've got a slope of 1 over 1, and that does actually simplify. 1 whole divided by 1 is just 1. So our slope is 1, and now I'm switching back to blue. So the slope of this line, which is also represented by the little m, this little m is equal to 1. Step 4, we are going to substitute the actual numbers that we calculated for the y-intercept and the slope into this equation. Y equals mx plus b. I'm switching back and forth between my colors. So first, y equals, we're going to substitute in our slope. So we're going to replace the letter m with the actual number that we calculated, which is 1. So that goes in there for the m. And then we're going to take our 8, which we identified, the number 8. Number 8, that is our y-intercept. And we're going to replace the letter b with our y-intercept of 8. So that leaves us with a equation of y equals 1x plus b, right? Slope of 1 times x plus b. And you keep the y and you keep the x in there, because that's what tells you that for any x, right, you multiply it by the number 1, you add a to it, and you get a y, and that's why you draw a line. That's how a line gets drawn. Now, if we erase some of the stuff that we did right over here, and you can see our line. So y equals x plus 8. That is the equation of our line. And notice, I didn't put the 1 in here. I removed that 1 because just like in the previous example where we had a slope, y-intercept of 0, and we got rid of that plus 0, you don't ever have to put, if your slope is 1, or if your slope is 1, you don't have to put 1x. It's just assumed. It's implied. If you have an x there, 1 times x is the same as x. So you don't have to put the 1. The proper way to write this with a slope of 1 is just y equals x plus 8. So here's our y-intercept of 8, and you can see this line is going to the right 1 and going up 1. Every point on this line is going up a ratio of 1 to 1. 1 up, 1 to the right. 1 up, 1 to the right. And so that's our slope. So this looks good. So let's put that in as our equation. Y equals x plus 8. Success, 9 points. Yay. All right, you can see these lines are getting a little more sophisticated. We're going to jump it up a level. We're going to go past 36. We're going to go to level 81 right here. Let's see what an 81 problem looks like. Look at this graph. All right, I'm looking at it. We're looking at this graph. And then what is the equation in slope-intercept form for this line? Let's do this one example and let's call it a night, folks. Here we go. Here's my 4-step process to create a specific equation for this line. All right, here we go. Let's get my desktop set up. Step one, let's find our y-intercept. And right there, that is my y-intercept. That is where my line is crossing the y-axis. So, step one, we have identified our y-intercept. So, the y-intercept, or little b, is equal to negative 40. Okay? And the coordinate there is 0, comma, negative 40. So the y-intercept is negative 40, but I'm going to write this out as a coordinate so I can use it for the slope. So here we go, 0, comma, negative 40. That is going to be my point 1. Now I've got to find another point on this graph where I can see the black line and all the gray grid lines behind it line up, so that I have a nice little point that is easy to use. It looks like it happens right there. That looks like 40 comma negative 10. And it also looks like it's happening right here. And I'm going to use the second point right here. It looks a little easier to read. And my second point is 80 comma 20. That's going to be my point 2, 80 comma 20. Point 2, right there. I'm just going to skip that one I did in the middle. All right. Next step, step 3, let's find the slope. And once again, so point 2, the 80 is going to be my x coordinate of point 2. I'm labeling all of the points, all the coordinates. The 20 is my y coordinate for point 2. That's what y2 means. And then over here, negative 40 is the y coordinate of point 1, and 0 is the x coordinate of point 1. So I've got all my points labeled. I'm going to go calculate the slope. I'm going to use this formula using the y-intercept as point and point 2. All right, so I'm going to take the y coordinate of point 2 and I'm going to subtract the y coordinate of point 1. So that's 20 minus negative 40. Notice those minus negative, the two negatives there. And that's y2 minus y1. And then underneath, I'm going to do x2, which is 80 minus 0, which is x2 minus x1. And here we go. So this slope is going to be 80 minus 0 is just 80. 20 minus negative 40. That's two negatives. This minus a negative, that becomes a positive. So then that becomes 20 plus 40, which is 60. 60 over 80 is my slope, and now I have to simplify. So first I'm gonna, it looks like 10 is a common factor, so I'm gonna take out or divide both sides by 10. That's gonna leave me with 6 over 8. And then that looks like it can still be simplified by the number 2. 2 is a common factor for 6 and 8. So 6 divided by 2 is 3. 8 divided by 2 is 4. And my slope is 3/4, or 0.75, 75 hundredths. So slope, all this work for step 3, my slope, or little m, is equal to 3/4. All right. Now I've got everything I need to write my equation. Move this over a little bit so we have a little more room to work. Here we go. So I've got my y-intercept, which is 40. I've got my slope, which is 3/4. And now I'm going to substitute the numbers that I calculated, the slope of -40 and the y-intercept of -40 and the slope of 3/4. I'm going to substitute those real numbers in and replace the letters m and b in the generic equation. So here we go. Let's do that. So your generic equation is y equals mx plus b y equals mx plus b. And I'm going to take this -40 and I'm going to replace the letter b with the -40. And I'm going to take my slope of 3/4 and I'm going to replace the letter m. So what do we have? Get rid of this little thing over here so I have more room. I'm going to end up with draw. I'm going to end up with y equals 3/4. That's my slope, replacing the m. X, we need the x and we need the y. Don't forget those two variables. Those are the only two variables that make it. Minus 40. Okay, there you go. So recognize this. Your y-intercept is -40. So when you substitute that -40 in for the letter b, you basically get, y equals 3/4 x plus -40. Plus -40 is the same as just minus 40, right? So don't write the equation as plus -40. Just take the negative y-intercept and put it right in there. And if you look at our line, what do we see? Y equals 3/4 x minus 40. So if you look at this black line, the new equation that we came up with is the only equation in the whole world that can represent the line that we see down here. We cross the y-axis at 40, and then every point on that line is going to be some ratio of 1, 2, 3, 4, a slope of 4 horizontal to 3 vertical. 1, 2, 3, right there. 3/4 is our slope. And so very clearly, this equation represents this line. All right. Let's enter this in and see how we do. Y equals 3/4 x minus 40. Submit. Super. Thank you. Thank you, iXL. And thank you guys for watching. This is a longer video. It's 35 minutes. But, this really is going to catch you up on essentially like a whole week's worth of stuff in class. So, 140 minutes, 35 minutes. This, I think, is pretty efficient. So good luck. You know how to get at me. Email me, office hours, whatever you need. Have a nice night.